I'm starting up the stream. Looks like the stream is running. Hi everyone, I'm TigerHawk23, and hopefully today we can finish the slicing methods in our Python implementation of a Deque. The standard library collections.deque does not do slicing at all. It's not implemented. But I kind of want it to, so we're going to keep trying. Alright, first thing I wanted to do, int slice, okay. Slice objects have a method called indices, and if you pass this method a number, that is the length of the iterable that you have, it will calculate all the indices that you will go through with a start, stop, and a step. Like you could use a range object with those values, and you would get all of the objects that your slice would refer to. So we're going to do that instead of all this stuff to calculate the start, stop, and step manually. We're not going to do that. And I also want a separate method called slice. And that's going to get a slice of nodes of the Deque. It's going to be something like this stuff that we have repeated here. So start, stop, step equals s.indices, and we have to pass it the quantity so it knows how long the iterable is. Our sequence, I should say, because it is a sequence. If it has indices like this for a slice, it kind of has to be a sequence. So we have those values. Actually, we can do R is a range of these things. Start is the start, so we have a range object out of these indices, and we have to unpack that. So, and that's the first index. So, and this will yield nodes, not elements. We're gonna have a while start in R. That's our range of indices. We actually have to current equals neighbors. We don't care about the others. Self.neighbors, okay. So that's the first node. And while start is in range, we're going to yield the current node, and then self.iter current, okay, and that's our iterator that we're going to use. So we're going to yield the current one, and let's call this index, because it's not going to be the start very long. So the index we're starting with is the start, first of all, and then need to pass it that. The neighbors of this index, and here's the current node. And then we're going to iterate starting at that current node. Oh. Self.iter. We don't know if we're going forwards or backwards. If step is more than 0, sorry. If step is positive, otherwise self.reverse iterator. And then whichever one we want, we're going to call that and pass it the current node. Okay. Am I doing all these right? I hope so. Where is RevIter? Takes a node, etc. Okay. Great. That should work. Alright, where was I? Here we are. So we find the neighbors of the starting index, and then we go either forward or backward, starting at this node that we just got. And then while the index is valid, it will yield this node. And then in range, absolute value of the step. We're going to try to skip something, the next one of our iterator, and if we get a stop iteration error, we will break and we'll just be done. Should it yield first or after? This is possible off by 1 error. So if the first index is, let's do this, index not in R, just return. That means we are done. But if it is, then we will yield at least 1, and then try to skip to the next one, and stop when necessary, and we need to increment the current index by the step. Okay, so this should just yield us all the nodes we're interested in. Okay. If it's a slice, if we have get Then we want to make a new one of those. And make a copy. Element node.element for node in, what did I call this method? Slice. Self.slice, and we pass it I is our slice object. And we can just return that. Okay. For delete, for node in self.slice of our I, we want to remove it. Remove node. Okay. Now if it's set, then what? Set is going to be more complicated. Because this is the one that can potentially change the size of our sequence, but maybe not. With a list, if you have an extended slice, meaning a slice with a step that isn't 1, then it can't change the length of a list. It will check the length of whatever iterable you're trying to use to reassign, or it will exhaust it and check the length of that. And if it's not the exact same length as the nodes you're trying to replace, it will simply give you an error message. So rather than do that, because I don't like that behavior, to be honest, it's something that you should check for yourself if you have an iterable that you think might be a different length, and it's an expensive operation to retrieve for some reason. You should save it and check yourself first, and then if it's not, you'll have to see what's up. For set, let's try these first. Do I need any of this? I don't think so. No. Okay. That was a large block of stuff I just deleted. Wow. Over 30 lines, that's pretty good. Let's get rid of that, yeah. So, if it's get, then we want to return another deck of all these elements with new nodes. Because if we just have the nodes themselves and just construct it like that, then that would be also modifying our original. We don't want to do that. For delete, we'll just remove the node. If it's set, pass for now. Let's look at our testing. Make a list out of this. check whether the slices look the same. Delete those. Check if the result is the same. And then reset. Okay, let's see what happens. Let's just see what happens. That printed a lot of stuff. A, B, C. Start, stop, step. That's a whole bunch of... What is that? Why does it print a whole bunch of A, E, F, G, H? What in the world? That's very wrong. Okay, let's do something simpler first. Let's start with that. All A's. Why? B, E, F, G, H. It's the right length. But why exactly is it doing that? Get, set, complete. If it's a slice, node.element for node in slice I, it's always the same element and the same node. So why is that? Self.slice is always returning the same thing. Oh, it's just always yielding current. Okay. There we go. Now there's two. Why did it do that? Oh, so I'm not actually iterating over it. Okay. There we go. A, B, C, D, E, F, G, H. Okay. How about backwards? And now it is backwards. Good. Okay. Now let's reactivate that part again. Okay. None, none, and 3. Should be A, D, and G. Oh, because we skipped first. None, none, 3. Doesn't work. Beginning to end. So this is, the first one is getting every third, and the second one we've deleted every third. So we should have, start with A, skip B and C, D, skip E and F, and get G. We've skipped A and B, gotten C, skipped D and E. How about, where'd it go? This over here, I think. Isn't that what we had before? That doesn't work? Yeah, no. But see, I don't want to skip a bunch. The only problem with this was that it repeats one first. B, C, D, E, F. So this is an off by one error, most certainly. While index is in the proper range, step is going to be at least 1. I don't think this is actually necessary. Okay. I want to yield something, and then try to get the next one. I want to yield something and skip to the next one. That is what I want to do. It yields the current one, and then tries to get the next one, and that is already the next one. Oh, I have an idea. Equals next operation. So there's at least one. Okay. Let's add this thing back. If index not in R, return. And then we know there's at least one. Okay, how about that? That's good. That's very good. These should all be able to be none, in theory. This is good. No output means no errors. And it's only taken 24 minutes, so that's awesome. All right. Cool beans. Cool beans. Now, the set method. I could just say not implemented. And it isn't yet, but I kind of want to. So this is what would happen when we have, when we say some slice of our sequence equals some other iterable. So that takes the elements of the iterable and puts them into our sequence in the desired locations. For node and value in zip self dot slice I and the choice element. because in this case, if it's a slice, it has to be an iterable, not just one object. No.element equals value. That's the very basic naive implementation. This doesn't handle different lengths of slice and iterable. But let's see about this first. How to test this exactly? Let's get that out of the way. D A B C equals range of stuff A, B, C. You can slice range objects. It's handy. E, A, B, C gets same thing. Not equals E. Okay. So this will say this particular slice. Oh no, this should be, I want these to be exactly the same length for now. 4, 8. Range 8. Let's see. Perfect. Cool. So that's good so far. And it only took 4 minutes. What next? Now, how about things that change the length of the iterable? The strategy that lists use is check the length in whatever way necessary first, and then raise an error if it's an extended slice that would change the length of a list. Or you could do as much as possible, and then if it's an extended slice, you just kind of stop when you've done a certain amount. Like if you are trying to replace 2 things with 7 and it's an extended slice, you could just do 2 and then stop. And if you're trying to replace 7 things with only 2, you could just do 2 and then stop. If I do like 15, this will be an error. You can't do that with the list. But what would we want to do? That's what we have to think about. I don't like the behavior of exhausting the iterable, because what if it was an expensive process to retrieve those values? Don't want to just get them and then find out that they were not correct, not the correct, length of iterable, and throw them all away. How about Ford? People who know me are very familiar with this expression in the old Dilbert animated series. Like the first episode basically was the name. They want to make a new product, and so obviously the first thing they have to decide is the name, because the name is how you decide what to build, not, focus groups or market research or knowing what the company does. None of those matter. Apparently you need to start with the name. So they have a bunch of engineers sitting around a table trying to think of a name for something that doesn't exist, and it just has to be a good name. That's their job for the day. And they get people in from, marketing and accounting, etc. And one of the marketing guys, Walter, and his coworkers say he's good at this creative stuff. In fact, he just named his kid last week. And how is Walter Jr.? Oh, she's fine. So he thinks he has a name for the product, and he says, how about Ford? And he looks so pleased with his originality, and Dogbert says, that seems to be taken by the Ford Motor Company, and his ears go way up, and Walter runs out of the room crying. It's great. How about Ford? I think that's taken. Anyway, what are we even doing here? Get, set, delete. This is a lot shorter than it was last time. I'm happy about that. Okay. So next thing we will be doing is assigning to things that change the length of the list. Let's use slices of 1. I mean, steps all of 1. This will not work because I go through all the nodes and then I stop. While the right way to do it would be to delete excess nodes and go through the remaining nodes in our slice and delete those, and then go through the remaining objects in our iterable and insert them into place. So let's just do that, because this has no chance of working, because it doesn't do that thing yet. It's not implemented. So let me go and do that. Get, set, okay. So now we will want to, this is for the int, sorry, for set, okay. And let's move this up so it says get, set, delete, because it's the get, set, del method, so it's going to be get, set, del. So there. Okay, so we've zipped through both of them, and now we want to, so this self.slice I is all the nodes in our deck that are referred to by this slice. and element is just our sequence that we're going to put things in. So we've gone through both of these in parallel, and if there's still stuff in the slice of nodes, then we want to remove them. Let's say if step is not equal to 1, return, and we're done. Otherwise, we want to continue doing stuff. So this, instead of exhausting your iterable and giving an error, if you're trying to, if you have an extended slice and you have different lengths of sequences that you're working with, so if this slice is of a different length than this element, and you don't have a step of 1, then it will, a list would check this first and then raise an error. This will do all the substitutions, and then if it's an extended slice and there's stuff left, then it will simply end instead of giving an error. So you should check that yourself first. So I'm going for go ahead and change stuff rather than exhaust an iterable. I don't know. I don't know if there's no perfect answer here, because you should send in good data, please. Thank you very much. If step isn't 1, return. Okay. Do I have an insert node? Just a single node. Get set, delete neighbors, distance index, reverse. I want to insert a single node. I know I have remove somewhere. Remove in place? No. Remove node. How about insert node? Very similar. Insert node. If there's a prior node, there's something prior, then node.prior.next equals no, this needs node and value. Oops. N equals a new node of our value, the element that we're passing in. So if there's a node.prior, then instead of saying the prior's next one equals the node, here's the node.prior, and node.prior, the next one is going to be node.next. So the next one is this. So instead of doing that, we're going to say node.prior, node.prior.next equals node.prior.next and node.next.prior. So we have node prior. So the prior one, should this just use get neighbors? This should use get neighbors. No, if it uses get neighbors for everything, it's going to be going through the entire deck all the time. I only want to do that once per operation, honestly. If there's something prior, then we say the prior's next is this one, and the node's Actually, are we inserting after or before? That's a good question. Insert after. Insert before. I can see there's going to be duplication that I'm going to have to fix. So for inserting something after, I'm going to have to see about forward and backward. Oh dear. Oh, I'll just swap these if I reverse them. Where's reverse? Come here. Come here, reverse. Here we are. Insert after, self dot, insert before, equals self dot, insert before, self dot, insert after. There. And where is it? Somewhere. Okay. So for inserting after, then we want to say if there's something after, if there's a node after this, then we want to say this node's next one and the next one's prior one point to this new node. And that's it, right? And if there's nothing after, then that means this is the last one. Then node.next equals n. Node.next is always n. And the difference is self.last equals n. Okay, now we can take out this and move it up here. I think that's pretty much it. Okay. Right, then if node dot, oh no, because we've just assigned node.next, so obviously there will be a node that we can't do that. And I don't want to lose the references, so node.next and node.next.prior. Let's just do that, huh? Fine. Equals self.last equals n. Okay. Copy paste. If there's a prior, then the prior should be prior and next. Otherwise, prior is equal to the first one equal to node. Okay. So we can insert after or before. So if we're going, if our step is negative, we will be inserting before. and if it's positive, we'll insert after, wherever it went. Okay. Isn't that weird that the one with the slicing is shorter so far? Anyway, okay, we've determined what to do if we have an extended slice. We just stop. We just do the minimum amount, and we don't change the length of the iterable. Otherwise, replacement equals, let's just say replace equals self dot insert after if step is positive, otherwise it's self dot insert before. And let's actually call that insert because that's what it's doing. So now that we have established that the iterable that we were passed is the same length as the slice that we wanted, did I really spend 20 minutes not really doing anything? Wow. I got some methods in there. Anyway, we're either going to insert after or before, so we will node and value. So we are keeping track of the last node. Should that return the next one? Yeah, I think so. Where to go? Return n. Okay. And it'll return the new node, allowing us to continue doing stuff. Assuming I can find my method. There we go. So if we're stepping forward, if the slice step is positive, we're going to insert after. If there's anything left to insert, if this is larger, this will matter. Otherwise, it'll insert before a bunch. So we'll have for node and self dot slice, I want to retain this. And keep going through it. Okay. In slice, and that's the remainder stuff. So if this is what we're doing at this point, then we have to delete all this stuff. Dot remove node, this node. And in the case that the element, the iterable that we're assigning to our slice is larger then we want to keep inserting into it. Oh, I was about to write this. Don't really need that. For value in element, we want to insert it after the most recent node, which would be this. What if there is no node? We should say node starts somewhere. Okay. What if there's nothing? What if the slice is empty? Then where do we put it? I know how to get the rest of the nodes if we have extras, but what if we have extra elements? And no nodes. This works so far easily if we have, let's take this out for now. If we know that we will have this assigned. Otherwise, not so much. So we'll do that first. Insert node value. Okay, let's see what happens so far. Step. Where's step? If step not equals 1. Oh, I never, oh, because I did that over there. And I don't know what the step is. Okay. What's SLC? Slice, that's just the slice object that we can iterate through. And I is the slice. If I dot step. Because the step doesn't change with the indices, I believe. Right? No, it might be none or something. So let's do that. And E equals I dot indices dot quantity dot step. No, it's 2. Okay. Alright. Turn that back on, go here. That didn't work, because of course it didn't. 0, 1, 2, 3, 4, 5, 6, 7, 14. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. That's wrong. Obviously. should have gone 0 through 7 and then kept inserting. For value and element. Oh, I kept inserting after the same node. I have to do node equals insert. So that'll be the new node. So I insert after a certain node, and then it gives me back the next one that I have to work on. 7, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. How odd. How odd. Why does it do that exactly? So this is definitely wrong, as you can see. So why does it start from... Oh, element just goes through again. I don't want that. There we go. Just want to go through the remaining ones. Alright. That's better. Maybe. I still have stuff. Why? Okay, let's look at our test cases. So we have, when we have just some slice equals some other thing, I mean when we have an empty slice, none, 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 should be equal to range 15. So this should just put them all in there, correct? Let's just say range 15, see what happens there. Because I can't... Wouldn't that be an error? Oh, no, it's there aren't 15 things. Why isn't this crashing? Oh, because it's all a step of 1. Right, okay. So when we have a step of 1, it's all of those elements from a certain value to a certain value. We can just do, you know, range 15. It doesn't... I don't think it matters, does it? No. This time there's no node. So that's not a happy thing. Can't do that. Okay. So when we have none, 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 that should be an empty list? Really? That's not supposed to be empty. None, none, none. Oh, maybe it's something in the delete. We deleted stuff. Print, set, print, delete. Now we'll see which one is the problem. Oh, they're all in delete. That's odd, except for this one. We say delete none, none, none. That should delete the whole thing. Delete, starting from 1, none, 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 should delete everything. Oh, I'm going through the... No, delete shouldn't be impacted by that. Get set del. What the? When we do none, 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 and we try to delete, that should delete the whole thing. And it's not deleting the whole thing. Why is that? Node and self.slice I. It was working before, but not now. Let's take out that part. Now it's good, but when I add stuff or change, and then I delete and it turns out different. If I set things first and then delete, the delete doesn't work. And it's the none, 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 one, none, none. These are the same. And these would be the same, technically. None to 0. Should be empty. Okay, let's save this smaller one. Oh, yeah, it's still. Let's put these back in there. How strange. It messes up on the delete and it doesn't delete them. Not currently sure why. Here's our slice and here's our element. We zip through both, setting. First we set the element to that value, and then we say, here's the step, if it's not one, return. And then we go through the remainder of the slice and remove the node. And then we go through the remainder of the elements and we insert them as new nodes. Why does it do that? We should have nothing and we have A through 14. We should have A and we have A, then A through 14. We should have 0 through 13 and then H. We have 0 through 13 and nothing. H, and so we have 7 through 13, 8 through 14. So a slice of none, none, 1 is basically just a shallow copy. Just refers to the same sequence. So A through H should be okay. Let's just focus on ones that change the length. None, 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 1, none, 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 negative 1, none. This one is okay. And none, none, 1. So first, this is that, print the what's its. And then we try to set it to something different. And then we delete certain values and check them again. Okay. So when we do none, 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 that should, and it's only when we try to delete after setting something else. Let's do the following. Print this. Change them. Print that. Delete both. Print both. And wait for input. Okay. So we have A through H and A through H. That's good. We change them to be 0 through 14. That's good. And then we say eight, 9, 10. Did I not change the quantity here or something? That's probably what I did. Insert doesn't change the quantity. Yeah, that's important. Let's go back, reset all my testing stuff. And put those things back in and see what happens. Remove node, insert node, insert after and before. Now let's see what happens. Oh, that's better. So when we set, we're supposed to trim the last one. Okay. Except for the last one. So we did, so this is forgetting the last H. Why is that? Remove, change the quantity. Okay. And I believe remove node changes the quantity. Good. Okay. So we go through each node and value, and then we say this element gets that value. So we have A through H. We change. That was a lot of debugging to realize that I forgot to change the quantity, huh? Anyway. So we iterate over both. So we have A through H and 0 through 14. And we say instead of A, we have 0. Instead of B, we have 1. And so on, 0 through 7 are replacing A through H. Oh, no. It's replacing, shouldn't replace A through H. That slice should not include the H, but it's removing it. What happens if we have none to -2? Then it removes both of those things, huh? It's getting rid of everything after. That's not good. Okay, why is it doing this one? Replaces all of those. It replaces 0 through 7 and then inserts 8 and 9. But it truncates everything else. I thought so. This is the thing with, it'll work if we have a node and we're just doing that for now. So let's change it to 7. Okay. So we have 0 through 7, but it was only supposed to affect the first, 0 through 7 objects. And then we delete the 0 through 7, and we're supposed to be left with these things. But we are not. And that actually, it has C, D, E, F, G, H, has the rest of the thing. So why does it omit everything? Let's focus on that one. Okay, it's this thing that's different. And then delete should leave us with something else. Oh, it's because the stop is the stop negative? What would happen if we had, so if we have -4, that stops halfway through. How about +4? That works fine. Slice of none -4 and none dot indices of length 8, 0, 4, and 1. This should be the same thing. Odd. I think it's something in this slice is not right. No, it got the slice properly. Only range 15. So I think the slice is working correctly. Just when we have a negative end, that should be the same thing. It should both have been 0, 4, and 1. So this is looking better, but still not correct. And it requires a node somewhere, basically. This 4 and -4 should have had the same effect. 4 works fine. Positive ends work fine, negative ends do not. Where do I even use that other than slice? I don't think I did I? Indices. I get this step. That's the only other place, right? And that's in set. So it's probably something wrong with this. Okay. 0, 4, and 1. Let's do also -1. Or, sorry, -4. None for none, and none -4 and none. None -4 and none. None -4 and none. 0, 4, 1, 0, 4, 1. So those are the same, those parts. And yet it works differently. Let's just print both of those. Oh, I can't do that, huh? Then how about some grouping? Just make it unconditional, basically. None for none with a deck of A through D, and a list of A through D. And that's 0, 4, and 1, right? And then it doesn't work. Oh, no, it does work. 0 through 0, 1, 2, 3, E through H, 0, 1, 2, 3, E through H. And then E, F, G, H, E, F, G, H. None, negative 4, none is A through D and A through D. It's those indices. And we should have replaced A through D with 0 through 10. Instead, the whole thing is 0 through 10. And then we should have deleted 0 through 4. What? Print. Do the substitution. Print. Do the substitution. Print. 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 Okay. 1, 2, 3, 4, and 1, 2, 3, 4. So first we print the slices, and then we print the indices, which seem fine to me, honestly. Didn't see any problem with that. Looked good. Any other prints other than this? No. So that's fine. So we print, and then we set, and then we delete. Print 0, 1, 2, and 3. Print 0, 1, 2, and 3. Set 0, 1, 2, and 3 to 0, 1, 2, and 3. 0, 1, 2, 3, EFGH, 0, 1, 2, 3, EFGH. And then we delete 0 through 3. Delete and delete. And then we reset it to these things. Okay. And none, negative 4, none. So we look at 0 through 4, should be the same as the other one. They should have the same result. But instead of 0 through 3, E through H, we get 0 through 3, and then 4 through 10. How did I even get those? I don't know. It's in that one as well. D0. Oh, negative 4. Right. 4, negative 4 is chopping 4 off the end. So, yeah, 0 through 10 should have replaced the first 4, but 0 through 10 here replaced the whole thing. EFGH. Okay, where did the EFGH go? It should have been inserting those nodes let's say instead of 10 items, I want a lot fewer. Let's go back to 8. A through D, 0 through 3, E through H, E through H, A, B, C, D, A, B, C, D, 0, 1, 2, 3, E, F, G, H, 0, 1, 2, 3, E, F, G, H. So there, it was okay. But once we get to things that are larger... Oh. Did that work? And then it didn't work at all. How strange. A through D for both. 0 through 3, E through H, 0 through 3, E through H. Those are good. E through H, E through H. A, B, C, D, A, B, C, D. 0, 1, 2, 3, E, F, G, H. E, F, G, H, E, F, G, H. A, B, C, D, A, B, C, D. 0, 1, 2, 3, E, F, G, H. 0 through 3, E through H. E, F, G, H, E, F, G, H. A, B, C, D, A, B, C, D. 0, 1, 2, 3, 4. 0, 1, 2, 3, 4, E, F, G, H. Why? Why did it do that? I don't currently know. Zero, 1, 2, 3, E, F, G, H. 0, 1, 2, 3, 4. How strange. What if we used 7? Would that still be correct? Shouldn't be making any difference at all. 0, 1, 2, D, E, F, G, H. E, F, G, H. So something's very wrong. And we will fix it next time. We made some progress. Good things. But, and is it related to remove somehow? I don't think so. Let's change these back to not equals again, so it only prints the problematic ones. A set, and it does that, and it's wrong. How about changing it to 8? And then everything's fine. Change it to 9. I don't know why it's doing this. Range 8. None. -4. None. 0, 4. Oh, negative. Different quantities. Okay. No, never mind. That's fine. So this is actually changing how much of our range object we put in there. Okay. And if it's exactly the same as the as what we would have with the positive index, 4 and negative 4, meaning a range of 8, then it is fine. But anything else is not fine. And I'm not sure why. So some stuff works that we added, other stuff not so much. And I already know we'll have to change things when there's no node, etc. So something is wrong there. Anyway, let's give it a larger value again, like 15. Supposed to put in 0 through 10, but only before this thing. And instead it truncated those. I don't really know why. Then it took out the 0 through 10 like it was supposed to, but the E through H just wasn't there. So that makes sense. I think the delete is okay, because it's doing what it should. If we start with oh, I didn't have that on, sorry. If we start with 0 through 10 and then E through H, and we remove the first 11, we should remove the 0 through 10 and end with E through H. If we start with just 0 through 10 and remove the first 11 objects, then we end with an empty iterable, an empty sequence. So the delete is okay, but the set, which is what I expected to have to spend more time on, is something we will have to spend more time on. Is it other stuff too? Just those. Just this one, actually. So, oh, how about, say, 8? Now that will fail too, right? Nope. Only the negative 4. That's very interesting. 11 should be the same as negative 4 for some of them. It is literally only that one. It fails. Negative indices don't work. Okay. We'll look at that next time. There's more to do, just in general terms. So, we made some good progress. Most of it works. It's just this negative index is not happy. Oh, it's because it gets more and more of this object increases in size, but this one does not. So that's why it's wrong. That's why that's the only one that's wrong. It's not the fact that it's negative, it's just the fact that it can grab more of this one while this one stays the same size. Something like that. Anyway, that is the stream for today. maybe we can finish this next time, hopefully, and not have too many more segments of getting a little more of the slicing done, because I do want to get this taken care of. So, but we're getting there. We're getting there slowly. So, remember to like, comment, subscribe. Other videos are on my channel. I archive my streams. Yeah. Thanks for watching, and I'll see you next time. Have a good one.